بسم الله الرحمن الرحيم. أبنائي وبناتي طلاب شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. كل عام وأنتم بخير. اليوم إن شاء الله سنتناول مراجعة على الوحدة الأولى في مادة الاستاتيكا. طبعا احنا عارفين مادة الاستاتيكا هي إحدى فروع المادة التطبيقية. The first lesson or first unit is friction. Welcome my dear student in our math program for second 3. Today we are taking first lesson about friction, revision of friction. My dear student, look the revision about friction. Look at, my dear student, the resultant of the two forces meeting at a point. This title from second secondary. If we have F1 and F2 are forces meeting at a point, the resultant its symbol R and measure of angle between them is alpha. The measure of the angle between R and F1 is theta. Then we have rule R equals square root F1 squared plus F2 squared plus 2F1 F2 cosine alpha. This resultant of the two forces act at a body or particle, between them angle alpha. This is magnitude. What is the direction? My dear student, tan theta equals F2 sin alpha over F1 plus F2 cosine alpha. This rule very important. Special cases. The first special case, if we have F1 and F2 have same direction, then alpha equals 0. We deduce R or resultant of the two forces F1 plus F2, and the direction has same direction of the two forces. Number 2. If we have two forces opposite directions, we deduce that alpha equals 180. Then R or resultant absolute F1 minus F2 and has the same direction of the greatest force. Number 3. If we have two forces are perpendicular, then we deduce that resultant square root F1 squared plus F2 squared and direction of R tan theta equals F2 over F1. Then find theta by using shift tan, F2 over F1 by using calculator. Number 4, if you have two forces are equal, each one is F, then R equals 2F cosine alpha over 2. This very important special case. Resolution of a force into two components. We know that, my dear student, if we have force F and we want resolve into two components, the first component F1, second component F2, then we deduce that angle theta 1, angle between F and F1, and theta 2, angle between F and F2. Remember, F1 may be equal to R or resultant. If F1, F2, two components, then we deduce what is the F1 or what is the relation between F1 and F. F1 equals F sine theta 2 over sine theta 1 plus theta 2. F2 equal F sine theta 2 over sine theta 1 plus theta 2. Number 2. In two perpendicular directions, look at F1 perpendicular F2 and theta angle between F and F1. Therefore, we deduce that F1 equal F cosine theta, but F2 F sine theta. Remember, we resolve F about two components. If two components are perpendicular, F1, F2. Then we deduce that F1 equals F cosine theta, but F2 F sine theta. Maybe theta equals 30 as example. Then F1 equal F cosine 30, but F2 F sine 30. Now we are translate to important title, smooth surface and rough surface. In static science, my dear student, we have two types of surface, smooth surface and rough surface. What is the difference between two surfaces? Smooth surface, it is a high vertical surface which has no friction force at all. Smooth surface has no friction, but rough surface, it is a surface which has a friction. Has a friction force appears when the body tends to move. If we, as example, if you have a car, this car stopped in a street. This car, we can move it by using force. If we move this car, we need more forces to allow it to move. Then the friction force appears when the car tends to move. Remarks, my dear student. Coefficient of friction of a smooth surface equal what? 0. Why? Because it has no friction force. But the coefficient of friction of rough surface is real number, must be more than 0, real positive value. Its symbol mu. It is a force founded due to touch to surface. If we put body on horizontal table, then the body will act on the table with a force named the pressure B R small. Also the table acts on the body with a force named reaction R. Regarding that, the two forces are reaction and pressure don't act on the same body, but one of them, the pressure, act on the table, while the reaction force acts on the body. And due to the third Newton law, each action has reaction equal in magnitude and opposite direction. Then we deduce that R equals B. R, reaction force, equals the pressure B. Static friction force. Now we are translate two important title. It's called static friction force. Look at the body. If we place a body of its weight W on a rough horizontal plane and small horizontal force B acted on the body, then hidden force resists the motion of the body. This hidden force is named the friction's force, denoted by F vector. It acts in the opposite direction of acting the force B. If the magnitude of the force B is not enough to move the body, then in this case the body is in equilibrium under the action of number one, weight, force, and normal reaction R, where W equals R. The horizontal force B and the force of friction F are equals. Then F equals B. Resultant reaction. Very important title. Look at R dash is called resultant reaction. It is resultant of normal reaction R and the force F. Look at R perpendicular on F. R dash resultant reaction of normal and force F. What is the rule? R dash equals square root R square plus F square. Remember, what is the difference between R and R dash? R normal reaction, R dash resultant reaction. In this case of limiting friction, R dash means equals square root R square plus Fs square. What is the meaning of Fs square? Fs square means static friction force. Fs mu sr limiting friction. Now we are translate to important example. Body of weight 39 kilogram weight. Placed on horizontal rough plane, two forces of magnitude 7 and 8 kilogram weight. And include an angle of measured 60 degrees, act on the body, so it become about to move. Then choose the correct answer. Static coefficient friction equals what? Choose the correct answer. 1/2, 1/3, 1/4, 1/5. My dear student, before we solve this example, we must know what is the difference between static friction force and kinetic friction force. My dear student, static friction force mu sr. What is the difference between static friction force and kinetic friction force? If the body about to move, this limiting static friction force. But if the body is moved, then we deduce kinetic friction force. Remember, Fs more than Fk and mu s more than mu k. What is the difference between mu s and mu k? Mu s is called static coefficient of static friction force, but mu k kinetic friction force. My dear student, look at the solution of this example. At the first, my dear student, we know that resultant of the two forces 7 and 8, angle between them 60, F equals square root 7 squared plus 8 squared plus 2 times 7 times 8 cosine 60. Then by using calculator, we find the value of F. We know that N equals W, normal reaction equal weight, and F equal mu Sn. By substitution, then we deduce that 13 equal mu S times 39. Mu S times 39. F equals 13. From the value of two forces which act on the body 7 and 8, F equals 13. The value of F equals 13, but the weight of the body is 39. We know that W weight equal normal reaction, R or N equal 39. By using the equation F equal mu Sn, then we deduce ms mu s equal 13 over 39. Answer is 1/3. Now we are translate to another one. A body of weight 39 Newton is placed on rough plane and tangent of static friction angle between the body and the plane is third. What is the meaning of the tangent of the static friction? Tan theta equal mu. Mu s equals tan theta, then mu s equals third. And the body is attached by force inclined the horizontal by an angle whose sine is 4/5, makes the body is about to move. Find the magnitude of tension forces. Look at the graph, represent body, its weight 39, force F, act on the body, inclined with horizontal with angle theta, we resolve F about two components, F cosine theta in horizontal, F sine theta in vertical. We know that we have normal reaction N and opposite F cosine theta mu Sn. Mu Sn, this is static friction force. By using two equation, horizontal equation and vertical equation, look at F cosine theta equal mu Sn, this number 1. By using substitution about cosine theta, 3/5 and third equal mu s. Therefore, we deduce that 3/5f equal third n. The second equation or vertical equation, f sine theta plus n equals 39. Therefore, by substitution about sine theta 4/5, then we deduce the second equation 4/5f plus n equals 39. We have two equations in two unknown variables, f and n. By using substitution or omitting method, we solve this equation by using third equation, n equals 39 minus 4/5f. Therefore, from 3 n1, therefore we deduce that the f equals what? F equals 13 multiply 15/13 equals 15. The force equals 15 Newton. Now we are translate to another example. Magnitude of the smallest horizontal force that makes a body of mass 10 kg in equilibrium on vertical rough wall where the coefficient of friction between them equals fifths equals what? Kilogram. Choose the correct answer. 20, 30, 40 or 50. My dear student, before we solve, look at in the opposite figure, my dear student, F equals N. And what is the N? Equals W. Normal reaction equals weight of the body, F mu N. Therefore, by substitution, 1/5N equals 10. Then the normal equal 50 kilogram weight. Therefore, N equal 50. Another example. A body of weight 50 newtons is placed on a rough inclined plane and is acting on a body, a force B along the line of the greatest slope upwards, given that the body is about to move upwards when B equals 30 Newton and is about to move down when B equals 20 Newton. Find coefficient of friction between the body and the plane. Remember, my dear student, we have two motion, upward and downward. Look at the motion upward. Moving upward, we have the weight 50. We resolve 50 cosine theta and 50 sine theta by using equation n equals 50 cosine theta. This equation number 1. Equation number 2, when the body move up, therefore we know that 50 sine theta plus mu n equals 30. Then when move up, my dear student, when move up, the static friction force mu Sn is down, but in the opposite figure, moving down, mu Sn is up. Why? Because the static friction force at most opposite the motion. Motion of the body down, mu Sn up. The motion of the body up, mu S down. By using moving downwards, we know that mu Sn plus 20 equal 50 sine theta. Therefore, by substitution, we know that sine theta equal 1 over 2. Then shift sine 1 over 2, theta equal 30 degrees. By substitution in equation 1, therefore n equal 50 cosine 30. Cosine 30 root 3 over 2, then n equals 25 root 3. Also substitution in equation 3 to find the value of mu, therefore mu equal root 3 over 15. Now we are translate to another example. A body of weight 16 Newton is placed on a rough horizontal plane. If the coefficient of static friction between the body and the plane 3/4, then magnitude of resultant friction force belongs to what? Choose the correct answer. 0, 16 closed interval, 0, 20, 16, 20 closed interval, 16, 26. We know that, my dear, then magnitude of resultant friction force belongs to what? Choose the correct answer. 0, 16 closed interval, 0, 20, 16, 20 closed interval, 16, 26. We know that, my dear student, this rule, resultant reaction R dash belongs to n closed interval, normal reaction n square root 1 plus mu square. Remember, my dear student, this is the value of R dash. Therefore, by substitution, then we deduce that R dash belongs closed interval 16 and 20. Closed interval. My dear student, this is very important to calculate resultant of two forces or resultant reaction R dash equals n square root 1 plus mu square. Remember, my dear student, n is normal reaction, R dash resultant reaction. Mu S meaning coefficient of static friction force equal what? F over n. Then R dash belongs to close the interval normal reaction and n square root 1 plus mu square under square root. Now we are translate to another example. A body of weight 30 newtons is placed on a rough plane inclined to horizontal with angle whose tangent is 12 over 5 and coefficient of friction between the body and plane 2/3. Find magnitude of horizontal force which act on the body and lies in vertical plane containing the line of the greatest slope of the plane to prevent sliding the body. Look at, my dear student, in this figure, the body moved downward to slide. Then the body, its weight 30 Newton. We resolve the body into two components, 30 cosine theta and 30 sine theta. When the body is slide, then mu Sn is up. We have two equations. The first equation, mu Sn plus f cosine theta equals 30 sine theta. Therefore, my dear student, by using substitution about mu 2/3 and cosine theta 5/13, sine theta 12/13. Therefore, we deduce that the first equation relation between normal reaction and the force F. The second, N equals F sine theta plus 30 cosine theta. Therefore, by substitution, N equals 12/13 F plus 30 times 5/13. From 1 and 2, we deduce that the value of the force F. Therefore, F equals 20. Now we are translate to another one. If the magnitude of limiting friction 60 Newton and coefficient of friction 0.75, then magnitude of the resultant reaction equals what newtons? Choose the correct answer. 50, 100, 150, or 200. Look at mu SN rules is 60, and we know that mu S equal 0.75. Then the normal N, 60 over 0.75 equals 80. We know that R dash equals N multiply square root 1 plus mu S squared. Therefore, by substitution, about N equals 80, mu S equal 0.75. Therefore, we find R dash, value of R dash by using calculator equals 100. Then this is answer 100. Now we are translate to another example. The force F equals 2I minus J plus 3K acts at the point negative 3, 1, 2. Find the moment of the force about point B, 2 to negative 1. Then find the length of the perpendicular from the point B to the line action of the force. At the first, find BA. BA vector equals A minus B. A point minus B point. Negative 3, 1, 2 minus 2 to negative 1. Answer is negative 5, negative 1, 3. This vector BA. Moment about B at the first, find BA vector. This is a position vector or R vector. Negative 5, negative 1, 3. By using determined moment about B, the first row IJK, second row components of BA vector, negative 5, negative 1, 3. But the force F, its components to negative 1, 3. By using calculator or minor determined to calculate moment about B equals 21J plus 7K. Therefore, my dear student, is moment of the vector of the force about the point A. Look at, my dear student, in the opposite figure, the norm of sum of moment of the forces about the origin point C equals what? Remember, before we solve or we choose the correct answer, we have two forces. The first force, 80 root 2 Newton, inclined with horizontal BA 45, and the second force, 100 Newton, which perpendicular to AB. the distance between the force 80 root 2 and C not 25. Remember, but the distance between 100 and C 20 centimeter. How? Because 80 root 2 inclined with angle 45. Then the distance perpendicular from C to the force 80 root 2 equals 80 root 2 sine 45. Remember this very important example. And we have other notes. What is the note? Direction of 80 root 2 clockwise with negative, but direction of 100 Newton anti-clockwise is positive. We know that we have two directions of moment, anti-clockwise positive, but clockwise is negative. Remember, my dear student, in this example, choose the correct answer, the moment about C. Choose from the four results: 0, 22,000, negative 22,000, 2,200. At the first, the moment about C, 100 times 20 centimeter, negative 80 root 2 times 25 sine 45. Therefore, my dear student, the answer 0. My dear student, by the end of this lesson, revision about friction, don't forget very important rules: mu s more than mu k, Fs more than Fk, or static friction force more than kinetic friction force. And don't forget R dash equals N multiply square root 1 plus mu s square. There is difference between R dash and N. N is called normal reaction, R dash resultant of reaction. My dear student, I am very happy to spend such time with you. Don't forget, math symbol, think, work, produce. Thanks. Goodbye.